Hey everybody, this is going to be a advanced video that's going to cover some Grasshopper stuff, but specifically how I make site models and get site information for the stuff we have in Studio. This is not related to any assignment we're going to do, and nothing that I'm going to cover in this video is going to be used specifically for any assignment. I just know that a lot of you might be interested in know how I make these things for Studio, how I get all that sort of CAD line work of the buildings and the streets and all that kind of stuff. So this is the process that I go through. So first off, Cincinnati, as well as many large metropolitan cities, provide what's called GIS information, or Global Information System. It's basically just pre-made line drawings of everything from streets, roads, rivers. Basically everything you see here, all of that is included. If you want Cincinnati's data, you would just download this. The problem is it doesn't come as CAD files. The CAD files would be massive because it's covering every street, every building, every block of an entire city. So you can imagine opening that in Rhino or CAD and it would just explode because it's just way too much information. So all this information is stored in a format that's called shapefiles that has to be ingested in order to make it into CAD formats that again can be used for design. This is traditionally done with a software called ArcGIS, which is used pretty heavily by planners and urban designers, and some architects will learn how to use it from time to time, but it is a rather complex software. It's also incredibly expensive, not very commonly used at firms because it is sort of a niche type thing, but is very powerful. However, a lot of that functionality has been made significantly easier through a Grasshopper plugin for Rhino, and that's what I'm going to cover. So eventually, it's going to be able to ingest our shapefiles and export CAD line work specifically to whatever area that we're looking at. So I'm going to show you that process. Now, I said this was advanced, and it is, because we're going to be using Grasshopper, so a basic understanding of Grasshopper is necessary, although what we do in Grasshopper is fairly simple as far as Grasshopper goes. You could make it more complex, but for what we need it for, fairly simple. However, Meerkat I found to be one of the most difficult programs to install and get running. In fact, it is so difficult that I can't really help you install it because it took me so long to figure it out. And I can only tell you the sort of pitfalls that I went through and what I had to do to figure it out. Just know that using the software, fairly easy. Getting the software working is extremely difficult. The issue is, since it was originally created, it's had to, it relies on Google data, and the way Google distributes its data doesn't work exactly in the same way it used to, so you have to set some things up. So even just installing it. So I'm on, if you just Google Meerkat Rhino, you'll find Food for Rhino, which is a great website that just has various plugins for Rhino and Grasshopper. There is a video that tells you how to install, and you can find a lot of people here who've answered questions on what you have to do. I would recommend reading all of this. I think I had to install the latest version, 1.61, but also the previous version of 1.6 to get all the files I need. I may have had to do another one, but I think the two of those was all I needed. Again, you'll have to figure this one out for yourself. Unfortunately, it's just a bit complicated. The other thing you will need is you'll need to set up a Google API key, and that's where it also gets complicated. So if you Google API key, it'll tell you how to do this and how to go through the process. Essentially, it's a 16-digit key that the program uses to communicate with Google and sets up you to have essentially a developer account with Google. When doing this, though, there is no need to do a paid account. So when going through, just don't ever sign up for anything you have to pay for. If you're doing that, it's unnecessary. You don't need it for what we're doing for this project or for this little software. So just avoid paying for anything. You shouldn't have to. All you have to do is set up your API key, which you'll have to go through this process to do. And again, you'll be on your own. This is a more advanced thing, and it's not really something we're directly covering it. I'm just covering it so you guys can see how I make these things. So again, you'll need this data, you'll need to set up an API key, and you'll need to install Meerkat. With Rhino 6 and beyond, Grasshopper is already installed. So this is what my little definition looks like here. Not very long, as I said. It's pretty simple, given what Grasshopper is and what it can do. I will go through these, but first I'll have to do some explaining as to what all this data means. So I'm going to hide this and open up, where did I put that? So essentially, when you download that QGIS information, or GIS information, it's going to come and look like this. Whole bunch of files that are essentially meaningless to you or I, and the program's going to understand, but we can't do anything with. You just want to make sure you know where this file is, because we need to reference it later on. So once we have, open that one up again. Once we have Meerkat installed and it's working properly, and again, good luck figuring that one out, you can go over to here, and there's a few things we'll need to drag out. So we'll need this guy, which is the shape file. We'll need a button, which that's actually just a standard button. So I'll just type in button to get that and put that in there. It's pausing for a second as it thinks. Then we'll need this guy here, which is I guess it's the symbol MK, and we'll need a file path. So going up here, we're just going to pull down MK, and we're going to type in path. So file path is basically just going to hook up a file that exists somewhere on our computer. And again, it's going to pause for a second as it figures that stuff out. I'm not going to use this though, because I've already got this stuff set up, but I'm just showing you how you would pull those things out. All pretty basic Grasshopper stuff. I probably also wouldn't attempt this if you have no Grasshopper experience whatsoever. I think a minimal amount is fine, because it's really not very complicated what we're going to do here. But a minimal amount is really going to be necessary to make use of what we're doing. So the file path, which if I right click on, I can select a new file. Essentially, we just want to go and select our shapefile file path. Actually, no, we don't. Sorry. What we want to do is, first we have to do this. So we need to essentially take those shape files that we did, and we need to crop them to a specific area, because if we did the whole city, it's just too much data to ingest at once. So if we press this button, I already have it open, but this little screen is going to appear, which when you first click it is going to be zoomed out to the entire United States/Earth. And it does say for developer purposes only, and that's because I did not use a paid API account. It's just standard Google. So essentially what we want to do is we'll have to add in files. So these little rectangles here are actually the size of the Cincinnati data. So the way you do this is essentially you go to add shapefile, and then you just want to, I have the shape files that I've downloaded from Cincinnati already open. Go through and just click on the ones you want. So I typically do, say, buildings, contours, wherever that is. Contours is right there. They were last done in 2011, so they are 9 years old at this point. And you can go through this and pick any information you think you'd want. You know, some of this may be more or less useful for you. I don't know if you need zoning districts per se as part of your QGIS, GIS, ultimately CAD data, but all of that is available. Whatever it is, just select several different things and hit open and OK. And then they will appear right here below. So that actually helps you find where your city is too, because I found it's really difficult to actually remember exactly where Cincinnati is if you're just sort of zooming into a map. It's much harder than you would think without any sort of indication other than satellite images. But anyways, once you've done that, then you use this little tool here to draw out an area. So basically, you do something like that. This is our site here at Findlay Market. This is going to crop those shape files to only work within that general area. And it will crop everything that we have selected here. So these are the ones I imported: sidewalks, road of pavement, green spaces, parcels, contour lines, building shape files. But basically, yeah, it will crop only this area, so we're not using all the data for everything. And it disappeared. and doesn't want to come back. Wants to hide. I don't know why. It's a little glitchy. I'm not going to say this is the best software in the world, but here it is. So anyways, once we have that, we'll hit crop shapefiles, and then it's just going to ask us for a location. So I made a new folder. I've already done this, so I just made a folder here and hit OK. It'll take a few minutes to cut those files down and place them there. Once they are placed, then we use the second little bit of a definition that we have here. So this file path we want to set to an existing file, and I already navigated here, so if I want to add contours, I will select contours. And we can only add one layer at a time right now. We could set up a more complicated definition, but for now, this is what we'll do. So essentially what I have here is this is the sort of data ingestion thing. The first thing that we're going to do is, so for all the data, I actually have a move command on because it will, in your Rhino model, move it to wherever it thinks it needs to based on global information, which could be really far from your origin. So I actually just use bounds in point space, which is basically the boundary of all the data you've collected. I found the area of that, which gives me the center. And then I basically did this point here is a 0, 0, 0. So it gives me a vector, which is a movement direction between the center of where my geometry is and the 0, 0, and it creates a vector that then I can use as a move command to move all the data at once. All that sounds rather complicated. It's really not that bad. Essentially, it's just moving it from the coordinates that exist in real life to the coordinates that you would need to actually work with. And then this is just, geo is just for geometry. It's just a box that holds things because I wanted to be able to organize that way. So essentially it takes in geometry per shape. So this is just the geometry. And you can see here it has this little dash line. That means it's grafted data, which I'm not really going to cover here, but just know that it's grafted data. And it moves it to the 0 point. And then with that, we can, let's see here, what's this command? Take that and make that into a polyline. I guess it doesn't come out as a polyline. It might come out as a series of curves or a series of points. And then I have a final move command because I want my topography to be lofted. And actually all these shapes actually have data with them. So if we were to pull this little data file in here, it's going to take a second because it's a lot of data. Essentially, it just gives the height above sea level for each one of the topography lines. And we just need to use that as a movement. In this case, moving in the Z direction to lift things up. This little command here is just sorting out that data. So I've opted to use number 2. So if you see here, number 2 is 512 or 524, which is just the height above sea level. So that will, this little item command here just makes that data list look like So this is a list of lists. This is a list of lists that only have one number in them. Basically, that number is just the height above sea level for each of our topography lines. That height is then made into a movement, which then will be moving all of our lines in the z-axis upwards. So now if we look at this in our Rhino model, we can see we have a whole bunch of topography lines, which is great. That's exactly what we wanted. Now to make them into something real, I'm going to actually just right-click and do bake, and I'll do group them. I'm going to put them on layer 1, which I will rename right after this. Definitely rename things as you go. And we'll call that rename contours, or actually just call that topo. Now essentially I just want to repeat this process by, I'm going to disconnect this guy because I don't need that anymore. So disconnect that wire, and I already have this connected in a road, so I'm going to do that one next. So I would just go back to file path, do existing, and this time I'm going to click on road pavement. And I don't need to adjust anything here. It's all going to be the same movement anyways, and I don't have to worry about adjusting up to sea level because it's all flat anyways. So if you see here, we now have the roads. So we would just want to essentially do the same thing of baking this. And I'll do layer 2 and then rename that. So we now have, you can see the topo lines are floating above, which makes sense. They're 524 feet above, and then the roads are on the seaplane down there. And that's kind of the basics of doing this. So you just want to keep going through and do all the different layers of information. And that's really about it. Make sure you name things as you go. So these things here, this is just a polyline. So each time you just take that data from the same place and plug it into the correct polyline. So if I were doing parcels next, I would just take this, plug it in here instead. I'm going to unplug the one from road just so it's not processing twice. And I could, I don't have to do it this way. I could just, keep it plugged in here as I change things, but I was just doing this to keep organized as I've named these. You only need to do this once really and just export over and over again and keep exporting to new layers. I was just doing this for my own sake and because I wanted to do it separately for topo since that's going to be elevated. But that's about it. It's really a pretty simple software, as I said. But the problem with it is, of course, installing it is quite terrible. It's really one of the most complicated things. There is another software that's a little bit easier to use, which is called Elk. It's both easier and harder. Getting installed is much easier. Using it's a little harder. And the problem is it's not nearly as accurate a data. Depending on what city you're in, they may have better or worse GIS data. Cincinnati's is very good. I've seen some other cities that is terrible or doesn't exist at all, in which case this won't help you. So if you're on co-op, this is something you may want to do at some point, and this is kind of the basics of how to do that. All right, thanks.